Hello, everyone. So now let's start our chapter 2. So chapter 2 is about graphical summaries of data, and we have 4 sections for chapter 2. 2.1, we're going to discuss graphical summaries for qualitative data, and then section 2.2, frequency distributions and their graphs is more for quantitative. And then section 2.3, we're going to talk about a little bit more about some graphs that we can use. And section 2.4, that's going to be a misleading graph. So let's start section 2.1. So let's first look at the survey we have here. So a survey regarding past preference as a student in this class. So we have the following categories to choose from. No, dog, cat, ferret, other. And then just suppose we've already done this survey during the class time, and then these is the results. And then we have actually 30 size of 30 data set. And then this is called raw data because it's still in the original form. And if we look at this raw data set, just similar to the one that we have from previous chapter, it's kind of hard to get information. So what we're gonna do is we try to organize it. And if nothing is introduced, the way we want to organize it is just basically as follow. We're gonna count how many students select no, how many students select dog, and then how many students select cat, so on and so forth. So now if we look at the organized results already, we have 2 no, 1 ferret, 4 others, 6 cat, and 7 dog. So pretty much everything considered. And if we look at the sum of all the numbers, we got 2 plus 1 plus 4, that's 7, plus 6, that's 13, 13 plus 17, that's 30. So we can verify it is 30. And the way we just used is called frequency distribution. So just make sure we put everything in the table format, and then we actually just construct a frequency distribution ourselves. And let's look at the definition for a frequency distribution. A frequency distribution is a table that presents the frequency for each category. So categorical frequency distribution is used for data that can be placed in specific categories, such as nominal, ordinal, level data. So categorical is same as qualitative. We're first going to look at an example for categorical frequency distribution or qualitative frequency distribution. So this is an example for political party affiliations of students from one class. As we can see, we have a couple of categories here. We have Democratic, we have Republican, we have other. So pretty much three categories. Then based on what we learned, if we just finish the counting and then put it in a table format, we generated a frequency distribution. Then now let's see what we have here. So we have category 1, 2, 3, and then we have the tally, and then the frequency just show the count of the number for each category. So 13 plus 18 plus 9, that's 40 total. Sample size should be 40. So now let's check. So we have 5 columns and 8 rows. So 5 times 8, that's 40. So no problem here. And then for this frequency distribution, all we need is the categories this is for sure, we have to have it. And then the frequency, we have to have it. But for tally, is an option. So if you put a tally there, it kind of guarantees that you did a correct counting. And then now let's look at relative frequency. What is when we have when we have the frequency column, we can further look at something defined as relative frequency. It is actually a pretty straightforward concept. Just use the frequency divided by total. Another way to look at the frequency column. So the count in this specific category is what percentage compared to the total inputs. So we can also just call it percent for relative frequency. So relative frequency distribution, again, is just a table that presents the relative frequency of each category. So it doesn't we don't usually just present a relative frequency distribution. So always we just gonna have the frequency and relative frequency together. So it's gonna look like, let's still use the party affiliation example. So we have party, so you're gonna put the categories here. So and then you can write down frequency, one column for frequency, and then one column for relative frequency. So that's kind of the structure for the distribution. And now let's finish the example. We have 13, 18, and 9. So the relative frequency is going to be 13 divided by 40, 18 divided by 40, and 9 divided by 40. So right here we calculated it as some number with decimals. So 0.325, 0.450, 0.225, and then the total is 1. So actually, if you just leave relative frequency like this, it's also okay. But for the total, then you have to just all through use 40 divided by 40. Or you can put percent, so 32.5%, 45%, 22.5%, and then the total is 100%. So this is okay, and also okay. So whichever format you prefer, you can use that one, but just make sure, just follow through, use always the same format. And now let's finish the pet example. So we have, if we go back to check the count, we have two nodes, one ferret, 4 other. So 2 nodes, 1 ferret, 4 other, and I think 6 cat and 17 dog. Now let's see whether it is add up to 30. It is. So that's correct. And relative frequency, we can just write like this. So 2 divided by 30, 17 divided by 30, 6 divided by 30, 1 divided by 30, 4 divided by 30, and 30 divided by 30. So this is a valid frequency. Now let's look at the graph. So we're gonna introduce something called a bar graph, or a bar chart. So it's the same thing. So a bar graph and bar chart is on top of the frequency distribution. Just use that information to make the data organizing in a more visual way. So we just generate this bar chart or bar graph. So for the political party affiliation example, we have the Democratic, Republican, others, so 3 categories. Then we have 3 bars. One important thing to mention for bar chart, the bars. Oops. The bars, they don't stay together. You can see a gap right here. So the reason we mention this is because later you'll see some graph called histogram, and then for that the bars stay together. So one is for the bar chart is for qualitative data. The later introduced histogram, that's for quantitative data, and then the best way to distinguish is to look at first thing categories. They just have categories, and then the histograms, of course, numerical value, and another thing is whether they have gaps between the bars. And other than the bar chart, we also have pie chart. Still shows the similar information. So after we got the data organized, we have the frequency distribution, and then or a relative frequency distribution. We can just calculate the percentage, and then just use the area represent each percentage in the category, and then make it a pie chart. Okay, I think that's all for section 2.1. For this video lecture, we'll just stop here, and then the next one gonna start from section 2.2.